Completing the square is a method to solve quadratic equations that we typically use when the a value is 1 and the quadratic equation can't easily be factored by product sum. However, we can complete the square for any quadratic equation, and in this video we're going to discuss a third method for completing the square on a quadratic equation when the a value isn't 1. So let's take a look. We have the equation 3x squared plus 12x minus 5 equals 0. So in this method, we know that the best way to complete the square, the most efficient way, is to have the a value be 1. And since the a value is 3 in this case, we could actually just divide every term by the a value to force it where the a value is 1. Right? So notice in this first step, I chose to divide each term by 3. You could add your constant to the other side of the equation first, and then divide everything by the a value. Either way is totally fine. I just find that choosing to wait to move the constant over to its own side of the equation helps me remember to divide all the terms by the a value. And so then I just simplified, right? 3 divided by 3, x squared is just x squared. 12 divided by 3, x is 4x. And then minus 5/3 is still minus 5/3. And this is why we typically don't prefer to complete the square when the a value is not 1, because we can get fractions. But we know how to deal with fractions, so we're not going to get scared by that, right? So at this point, we're ready to move the constant over, and it's just doing the process we already know about completing the square. So you have x squared plus 4x equals 5/3. Then you need to add the number that completes the square, which is half of your b value squared. So notice that I did 1/2 times the b value, which in this case is 4 squared, and I did that on both sides. There's no need to show your work like this, but I thought it might be helpful for you to see during this video. Then I simplified. 1/2 of 4 is 2, and 2 squared is 4. Okay, and so at this point I noticed that I had a fraction plus an integer, and I thought it would be easier to add my numbers together if they both had the same denominator. So I just rewrote it as 5/3 plus 12/3 as opposed to 5/3 plus 4. But really in your calculator you could just type in 5/3 plus 4 math frac enter and get it to be 17/3. So you could just type it in your calculator and make your calculator write it as a fraction. Either way is totally fine. And once we get to this point, I'm ready to go ahead and take my perfect square trinomial and write it as a binomial squared, so x plus 2 squared. And remember, the way you get the number in parentheses is just half of that b value. So 1/2 of 4 is 2, and that's why we get the x plus 2 squared. And x plus 2 quantity squared is x squared plus 4x plus 4, so we know we're correct. And so we've put it into vertex form, essentially, and this is the point where you would just use the square root method to finish up the problem, which I'll show in the next screen. So in this problem, or in this slide, we're taking the square root of both sides because we have already isolated the quote-unquote squared stuff, which was x plus 2 squared in this problem. So taking the square root of both sides will help me undo the squaring, and so we're left with x plus 2. But when we take the square root of both sides, we need to put the plus or minus to consider both options. And if I'm taking the square root of a fraction, personally I'm going to break it up into the square root of the numerator divided by the square root of the denominator, just so I have that visual reminder to make sure that I don't leave a square root in the denominator. And so that's what I'm showing on the second line. I'm rationalizing the denominator by multiplying by 1, because that's not going to change the value of my fraction. But I made 1 look a little different based on the denominator. So I know that square root of 3 times square root of 3 will give me just 3, which is okay because we want rational numbers in the denominator, and 3 is rational. But I can't just multiply the denominator by square root 3. I also have to multiply the numerator by square root 3, so I'm not changing the value of the number. And so then square root 17 times square root 3 is square root of 51. Square root of 51 can't be simplified anymore, so we can leave that alone. And so now I'm just going to isolate x by subtracting 2 from both sides. Notice that I put the negative 2 in front of the plus or minus, and then I just want to combine this into a single fraction. That's preferred. So negative 2 is the same as negative 6/3, and I chose that so both fractions have a denominator of 3, and then I can combine that to my final answer of x equals negative 6 plus or minus square root 51 divided by 3. And so there are many ways that you can start completing the square. This one might be the easiest for you. It's okay if it's not. You have 2 other options that I've shown, and it's ultimately going to simplify to the same answer either way. So thank you for watching.